All right, let's talk about something we see all the time, but maybe don't fully understand, the decibel. You see that little dB symbol everywhere, but what is it actually measuring? What does it all mean? Well, we're going to pull back the curtain and make it all make sense.
Seriously, think about it. It's on your stereo, it's in your car, it's on your noise-canceling headphones. This little number, dB, is supposed to tell us how loud things are. But, as you're about to see, it's not nearly as simple as a number on a ruler.
Take my watch, for instance. It's got this noise app, and right now it says the room is at 51 decibels. It even gives me a little green OK signal. But OK compared to what? And is 51 quiet? You'd think that 102 decibels would be twice as loud, right? Well, it's not. It's not even close. And to get why, we have to understand the incredible things our ears can do.
You see, the difference between the faintest sound a person can hear and a sound that's so loud it's physically painful is, well, it's astronomical. The range is massive. If we tried to measure that on a simple linear scale, 1, 2, 3, 4, the numbers would get so huge, so fast, they'd be completely useless. It just doesn't work. So we needed a smarter way to count. A system that could take this enormous range of sound and kind of squish it down into numbers that are easy to work with. And the secret sauce for that is something we all learned in grade school, the power of 10. Let's do a super quick math refresh. Don't worry, it's painless. The number 100 is just 10 times 10. We can all agree on that, right? A shorter way to write that is 10 to the power of 2. That little 2 up there, that's the hero of our story today. The pattern just keeps going. 1,000 is 10 times 10 times 10, or, as you've probably guessed, 10 to the power of 3. See? All we're doing is counting how many tens are being multiplied together. Now, believe it or not, you've just done a logarithm. I know, it's a scary-sounding word, but a logarithm is just asking a really simple question. It looks at a number, like 1,000, and it just asks, hey, what's the power of 10 I need to get here? And for 1,000, the answer is 3. That's it. That's all a logarithm is. It's a way to focus on that little exponent. And what this does is it turns these giant multiplicative jumps, 10, 100, 1,000, into simple little additive steps, 1, 2, 3. And that is the absolute magic behind the decibel. So here's the most important thing to get. A decibel isn't like an inch or a pound. It's not a fixed amount of something. It is always a way to describe a ratio between two things using that clever logarithmic scale we just talked about. It's always a comparison. Now, you might see these formulas and think, whoa, math alert, but don't sweat it. The only thing to notice here is that sometimes you see 10 log and other times you see 20 log. The 10 log one is for measuring power. The 20 log one is for stuff like sound pressure. Why the difference? It's just a math shortcut. It turns out that power is proportional to pressure squared, and that little squared 2 gets multiplied by the 10, turning it into a 20. It's just a convenience. Okay, so we've established the decibel is this clever ratio, but what do we actually do with it? Well, out in the wild, it has two main jobs, measuring how loud something is and measuring how much something has changed. And this slide lays it out perfectly. On the left, we're measuring a level. Think of it like a sound level meter at a concert. It's asking, how loud is this right now compared to a fixed standard? On the right, we're measuring change. Think of the volume knob on your stereo. It's asking, how much louder or quieter did I just make this signal compared to a second ago? So that first job is called sound pressure level, or SPL. That's what my watch is measuring. It takes the pressure of the sound waves in the air and compares them to a standardized, universally agreed upon reference point, which is basically the quietest sound a healthy human ear can detect. And this is so important. 0 dB SPL does not mean silence. It just means the sound is at the same level as that starting line. That second job is all about gain and attenuation. This is the language of music producers and sound engineers. When you turn a knob up on a mixing board, you're adding gain. You're making the signal stronger. When you turn it down, you're attenuating it, making it weaker. The decibel tells you exactly how much you've changed it. Okay, the theory is cool, but let's boil this down into something you can actually use. Let's create a little mental cheat sheet with a few really powerful rules of thumb you can remember. First up, plus 3 dB. If you remember one of these, make it this one. An increase of 3 decibels means you have doubled the actual sound power. So if you have one guitar amp on and you turn on a second identical amp right next to it, the total power has doubled. That's a 3 dB jump. Next, plus 6 dB. Now this one is linked to doubling the sound pressure. Because of that pressure squared thing we talked about,
When you double the pressure, you get a 6 dB increase. This one is often what our ears perceive as sounding twice as loud.
And here is the big one. An increase of 10 decibels means the sound power has been multiplied by 10. This isn't just a small step up, it is a giant leap in energy, a tenfold increase.
So, let's use our cheat sheet. Someone says, oh, the noise level went from 80 decibels to 90. That's only 10 more. We're trained to think of 10 more as a small, simple addition. So why is that way of thinking so wrong?
Because as we just learned, that jump of 10 more decibels means the actual sound intensity, the raw energy hitting your eardrums, is now 10 times more powerful than it was at 80 decibels. That is not a small change. That is a massive, massive change.
And that brings us to the single most important part of this whole conversation, why any of this matters to you and your health. Because understanding that decibels are logarithmic is absolutely critical to protecting your hearing for the rest of your life.
This is where that plus 3 dB means double the power rule becomes so important. Hearing safety guidelines use what's called a 3 dB exchange rate. If you double the sound energy, you have to cut your safe exposure time in half. Just look at this chart. At 85 dB, which is like heavy city traffic, you're safe for about 8 hours. But go up to 88 dB, just 3 more, and your safe time is slashed to 4 hours. Go up again to 91 dB, and you're down to 2 hours. By the time you get to 100 dB, you've only got 15 minutes before potential damage begins.
So if you take away only one thing from this entire explainer, please let it be this. What feels like just a small number going up on a screen is actually a huge exponential increase in the sound energy that your ears have to absorb.
So let's circle all the way back to the beginning. Now, when your watch says 51 dB, you know it's so much more than just a number. It's a precise measurement on a gigantic, logarithmic scale, all neatly packaged for you. It really makes you wonder, doesn't it? What other numbers do we see and use every single day that have a fascinating story hiding just beneath the surface?